everybody. This is the introduction to the whole project I worked on the past fall 2024 semester with my robot project. I'm really making this video to really showcase the work that I've done throughout the semester and also just show how cool the project was as well. And so if I go here to the screen and show you, these are the initial sketches that I had at the beginning of the project. I was really inspired by a lot of Star Wars like vehicles, especially the walking ones, like the bipedal ones, one that involved the legged locomotion as it was part of the project. And I was able to really use that inspiration and apply it to a bunch of designs. This one is inspired by the ATAP, which I'll show here a picture of it. So after that, here I have more of the visualization of the whole concept. I decided to do multiple views in order to have a more concrete idea of how it was going to look at the end. And being able to show the components all wherever they would likely go. Carry on to the second design that I had in mind for this project was also heavily Star Wars inspired. This one is actually the ATTE, which I'll show here in a picture. It's basically your six-legged locomotion, inspired heavily by a beetle, mainly. For this vehicle, because of the limitation of the motors, there had to be some system mainly pushing this big leg in the middle for both sides. That would be the main driving factor to keep the whole robot moving. More of a front view of the vehicle. This one is actually a very interesting design that is not really 100% of my work because it was inspired by AI. And I got pictures like here and there where you can see that I basically just like used that and gave it my own twist. Moving on with the preliminary design on SolidWorks, I ended up choosing the first design I talked about, and I carried over that whole visualization on sketches and transferred it onto SolidWorks. And so as you can see on the screen, I'm showing you the preliminary first version of what I really saw when I was like the first night I started working on this. And I tried to put as much detail, not to the point where like for example all the screws, but also to show like the kind of intricacies of how the mechanism would work and how it would essentially look at the end. I employed the third leg, making sure that each leg had its stability and having a passive joint link for each leg to keep that position when the motors are activated. I showcased the electrical components needed to make the robot move. Basically went all in with the whole three-leg design. Here we go, we can see some renders of the first preliminary design, having a more in-world look of how the design would look, and more of the scale relativity compared with a baseball, and showing a more real-life scenario, and just showing more of the structure, how it was. It would be the exploded view, the design, and pretty much entailing how this would end up looking. With the project becoming more and more serious and more defined, there was a shift with the idea of deciding how many legs the robot had in terms of for easier maneuverability and easier control, as well as a better look for the whole design. So as you can see here on the screen, the idea of having a third leg was completely scratched. It was a big decision throughout the project, as embracing bipedal locomotion robot required a little bit more of a challenge in terms of balance and control as well. It was imperative to have strong legs, and therefore the structure of the whole leg, for example for the passive joints, needed to be stronger. This decision, though, it did not come into play until later in the project, as the previous design was used that proved some failures and therefore had to be redesigned. As you can see right now, each leg contains this thick passive joint linkage that makes sure that the leg is able to stay at the desired configuration provided by both motors here at the top. With added detail, I was able to show how many screws I needed to use, how many nuts, how many grams of filament I needed for all these parts to be printed in 3D. All parts in gray color were printed in 3D at the Makerspace at Columbia University. Overall, it proved to be efficient and proved to be strong enough to make these strong maneuvers in order to move one leg at a time to accomplish the locomotion that was required by the project. Now to the exciting stuff, the actual physical stuff that I worked on. Now, as you can see, I needed to start with something small. Starting off with the leg, I made sure that the leg functioned as desired, and the mechanism with the parallel motors configuration would provide good results in terms of moving the foot to a desired location or to a desired direction. With the leg working as desired, I moved on into the rest of the robot. Now, with the whole robot fully assembled, both legs were able to be tested, starting with the development of a homing code program where both legs would be able to home at a desired position where the robot would have the most stability in order to start the whole locomotion of the robot. At first, the locomotion of the robot wasn't really at its expected movement because the strength of each leg was not good enough for the leg to be actually strong enough to withhold the whole weight of the robot. With a whole arrangement of redesigns and giving the robot a new makeover, I am able to present you the physical final version of the robot. The new design for the passive joint linkage is being utilized here, and it proved to be strong enough in order to give the robot the ability to move with no problem. As I'm showing more pictures, these are more angles and views of the final product of the design of the robot. As a way to test the rigidity and the extremities at which the robot could perform, I was able to put the robot in weird and not so comfortable configurations. As you can see here, the orientation of both legs is normal, but the angle between both the knees, as you can see here and there, is not proper. But the robot is still able to maintain its balance as well as stay upright with no problem at all. With the final product of the design, the robot was able to accomplish a speed of 2 centimeters per second. As it is not as the fastest as you would think, the way it moves and the sudden movements that are shown in the video do not provide a challenge for the robot because it remains stable and it remains strong enough to withstand any type of disturbances that it would possibly face on its course. Now that we are almost at the end of the video, I just want to reflect overall on the project. I was able to indulge in the practicing of new skills that I needed to attain in order to build this robot that I have right here. Especially reflecting on the design of the robot, I think I really did a great job in terms of letting my imagination flow. Not only because I took something that I got inspiration from and really gave it my own expression, my own twist, and being able to really visualize that whole idea and make it actually happen. In order to expand this project, I would definitely start looking into ways to more electronically enhance the robot and provide it with more sensors. With the use now of the Raspberry Pi,
is it is really easy to integrate all those sensors and being able to give the robot a sense of its environment. In terms of designing, I'd say I really try to design the foot of the robot and making sure that it's more adaptable to different environments, different terrains, so the robot can move through these environments and not have any problem. Additionally, as you can see, right now the protection for the electronics is very low, and so that could be definitely worked on later on, and making sure that it does not affect the weight of the robot and the whole calculation of its center of mass, so it's still stable when it's either both not moving or moving. Thank you so much for watching this video. I appreciate your attention, and I hope you had a good time watching my whole progress on this project. Thank you.